But it's a great honor to introduce the speaker of today, Professor Bart Baesens. He's a professor at the KULeuven in Belgium and a lecturer at the University of Southampton. He has done extensive research on big data and analytics, customer relationship management, web analytics, fraud detection, and credit risk management. He is also author of the book Analytics in a Big Data World. Professor Baesens will discuss the challenges when dealing with multiple channels of data and sculpting them into quantifiable value. With that, Professor, the floor is yours.
Thank you, Frederik. Good morning, everybody. I guess all of you are joining us from the European continent, so I can say good morning to you. Just a little bit of introduction about myself, not too long because this is the most boring part of my presentation, at least I hope so. So I studied at the KULeuven in Belgium, which is obviously one of the better universities in Belgium. Did a PhD there on credit scoring using machine learning techniques. And after that, I became a professor of big data and analytics at KULeuven. I'm also a lecturer at the School of Management at the University of Southampton, as Frederik correctly mentioned. My research is analytics and anything related to that. Basically, I have a PhD team of about 10 PhD researchers, all working on analytics. Most of them are actually being sponsored by firms like Coca-Cola, some financial institutions like bpost Bank, even some supermarkets like Colruyt, and so on. My research is nicely summarized on www.dataminingapps.com. There you will find all the different research tracks we are covering, such as credit risk analytics, marketing analytics, fraud analytics, and HR analytics. You will find some free stuff on there, including all the PhDs that have been done in my group. You can download them from the site. You'll also find some free YouTube movies discussing our research, and also some of the lectures that we're giving on the topic. There's also a newsletter, and you can subscribe to it if you want on our dataminingapps.com website. It's a 2-weekly newsletter in which we report some of the research results. Feel free to send me an email in case you would have any follow-up questions at the end of this presentation. In this very short presentation, I'm going to quickly set the stage, then we're going to zoom into the analytics process model and give you a bird's eye overview of the various steps involved. Then we're going to work out some key analytic model requirements based upon various of our industry collaborations. We're going to very quickly zoom into some new application areas into which we are also very actively doing research. More specifically, we will discuss social network analytics, business process analytics, and HR analytics. And obviously, we will finish with some conclusions. Well, if you want to do analytics, the first thing you need is data. And right now, we're being flooded by data. Undoubtedly, you have encountered the term big data before. The data is being gathered by means of various channels along which a customer will interact with your firm. First, there's web or email. As soon as a customer logs on to your website, he or she leaves behind a massive amount of data ready to be analyzed. The customer can also contact your firm by means of a service or call center. He or she can ask for a price quote or maybe even file a complaint. Surveys are also a very important data collection mechanism. As soon as you log on to a website these days, you will see a pop-up asking whether you would be willing to participate a survey relating to the site experience. Corporate data refers to transactional data. As soon as a customer makes a transaction, think about a product purchase, then all information about the transaction, such as the timing of the transaction, the location of the transaction, and the items involved, will be stored into massive OLTP, online transaction processing databases. And obviously, we also have various partnering organizations. These are data providers or data poolers whose core business is gathering data, cleaning up the mess in the data, building models with it, and then selling the results back to interested counterparties. You can think of companies such as Dun & Bradstreet, Equifax, Experian, Callcredit, TransUnion, etc. Now, all of this provides an enormous wealth of information ready to be analyzed using analytics. Here you can see a quick overview of the analytics process model. Roughly speaking, it has 3 steps. The first step is identifying the business problem and data selection and pre-processing. Identifying the business problem is of key importance. First, you need to clearly state what business problem you would like to solve using analytics. Do you want to tackle churn prediction? Do you want to tackle churn? Do you want to identify fraud? Do you want to see which customers are likely to respond to your marketing campaign? Or do you want to find out how customers use your website? It is very important that the business problem is stated first. Then, once this has been clearly defined, you can start selecting the data sources. Various kind of data sources, OLTP databases, some external data, maybe even some survey-based data. Then you're going to select and clean the data. Select and clean the data means that you're going to clean up the data for missing values, for outliers. Think about a person whose age is 300 years old or whose income is 1 million euros a month. Transforming the data means that you're going to enrich the data. You're going to connect it, enrich. A very basic type of transformation is calculating the age. Usually the age is not stored in any corporate database because that changes, hopefully, on a yearly basis. So instead of that, firms are going to store the birth date. Well, age is a derived data element. So it's a small transformation which you do based upon the date of birth. And you can think of more complex transformations in any analytical setting there. So this is the first step, identifying the business problem and pre-processing. This will then be followed by the analytics step, the data science step, in which you're going to build an analytical model to do something for you, to predict churn, to predict fraud, or describe how customers use your website. Once you've built your model, you will start interpreting it, evaluating it, and then deploy it into a production setting, which is the whole post-processing step. Basically, this is an iterative process model, and you're going to run through this whole process model multiple times. You can see various applications of analytics in today's industry environment. There's fraud detection, market basket analysis, social network analytics, churn prediction, which we already briefly referred to before, response modeling, customer segmentation, customer lifetime value modeling, and web analytics. These are just a selection of very popular analytical applications, most of which we also work on in collaboration with industry partners. Now, here you can see an example of a very basic analytical exercise. So at the top of my slide, you can see a nicely pre-processed data set. It has 4 customers, John, Sophie, Victor, Laura, and it has a set of predictors like age, recency, which is recency of the purchase, frequency, which is frequency of purchases made, like 6 purchases are made per month for John, and then monetary, which is the average amount of the purchase. And then you can see the final column is a churn indicator, which indicated whether that particular customer churned, yes or no. In other words, whether that particular customer left the firm, yes or no. So once you have a nicely pre-processed data set like this one, and obviously it's going to include a lot more observations than just 4, you can put it into some software like SAS, R, IBM, whatever kind of software, and build an analytical model. In the bottom right of my slide, you can see an example of an analytical model. This is what we call a decision tree. It's a very white box analytical model. You can easily understand it. If age is less than 40, yes. If frequency is less than 5, yes. Then my analytical model states that the customer is likely to churn. This is an example of an analytical model, decision trees. And it's actually one of my top 3 favorite analytical models that are being used in the industry nowadays. Now, where do you see the most sophisticated analytical models being deployed in the industry? I would say it's risk management. Because in risk management, analytical models, more than ever before, steer the strategic decisions of banks. If you're a bank, you need to quantify both your expected and unexpected losses for credit risk, market risk, and operational risk. Now, the way you're going to quantify those losses is based upon all kinds of parameters that you will estimate. For credit risk, this will be the PD, probability of default, the LGD, the loss given default, and the EAD, the exposure at default. Given the importance of those parameters in quantifying the expected and unexpected loss and the resulting provisions and buffers that financial institutions will hold, regulatory accords have been introduced, such as the Basel and Solvency Accords, to unambiguously quantify and qualify how those parameters should be defined and how they should be estimated. So the most sophisticated models these days in the industry you're going to encounter in risk management because of the impact of the model errors. In those areas, the impact of model errors or model risk, as we sometimes refer to it, is bigger than in most of the other areas. If you set up an analytical team, and actually this morning I did an interview for a Belgian magazine called Trends about this. If you set up an analytical team, you will have different job profiles that will collaborate. You will have the database or data warehouse administrator who provides you with the data. You will have a business expert like a marketeer or a credit risk analyst, and I'm sure many of you guys attending are business experts. You'll have a legal expert, which is going to tell us what data we can use, what data we cannot use when we start violating a customer's privacy, for example. You have the data scientist, which is the sexy term, or a data miner, which is an outdated term, and then you have the software or tool vendors. In other words, a multidisciplinary team needs to be set up. And as such, I believe that a data scientist should possess 5 key skills. First, he or she, unfortunately, there are too many he's for data scientists. Yesterday we had a meeting with the Brussels data science community. There were about 100 people present, and I think about 95 of them were males. We definitely need more females in the area as well that should possess all these 5 skills, being, first of all, quantitative skills, statistics, data mining, sometimes called machine learning, although I think this is a more boring term. But anyway, quantitative skills that allow you to analyze data in an unambiguous and valid way. Besides that, we also need programming skills. Believe me, there are not that many people that have good programming skills, and it's up to us, university, to actually work on that. Together with some of my colleagues, I recently wrote a book on Java programming, for example. So programming is very important because you will always need to tailor the data in such a way that it fits your business needs and your analytical models. Then we have communication and visualization. The data scientist is a multidisciplinary profile as he or she will collaborate with various people in your organization. One way to have easy communications is by using appropriate visualization facilities. And that's why many software vendors, especially SaaS, for example, are betting high on visual analytics. Then we have business knowledge. Before a data scientist can solve a business problem, he or she should understand the business problem. If I want to do a telco churn model, the first thing that I should know is I should understand the business of a telco provider. I should appropriately understand the difference between prepaid and postpaid telco contracts. Because the way you're going to define churn can be different in a prepaid or in a postpaid setting. So you need to immerse yourself in the business setting as a data scientist before you can start building analytical models. And finally, there's the creativity issue. Data science is a domain with lots of ongoing evolutions and new ICT developments. Think about the Internet of Things that you may have heard of. This is going to raise a tremendous new potential for analytics. We are currently working with a Belgian insurance provider called Ageas on the topic of telematics. Telematics means that you will have an iPhone with an app which is going to continuously track your driving behavior. Based upon your driving behavior, the insurance firm can get an idea about your risk, which can then translate into your claim, the price you're going to pay for your insurance. So you see, as a data scientist, you need to have a very multidisciplinary profile. Analytics is a term which is often interchanged with data science, data mining, knowledge discovery. And what it essentially refers to is extracting decision models like the decision tree that we already referred to, or other types of business patterns from a pre-processed data set. And basically, you have a distinction between two types of analytics. You have predictive and descriptive analytics. In predictive analytics, you're going to predict the future based on patterns learned from past data. You can make a distinction between classification, where your target variable is classification where your target variable is discrete. Churn prediction is an example of classification because you want to classify customers as churners or non-churners. Response modeling is an example of classification because you want to discriminate responders from non-responders. Fraud detection is an example of classification because you want to discriminate fraudsters versus non-fraudsters. In case your target variable is continuous, you have a regression setting. This is the case for CLV. CLV stands for Customer Lifetime Value Modeling. It actually reflects the total value that a customer is going to generate in the next 2 or 3 years, for example, to your firm. So in a regression setting, your target is continuous. Other examples are predicting sales, or in a credit risk modeling setting, predicting LGD, loss given default. In descriptive analytics, you're not going to predict, but you're going to describe patterns in the data. You're going to cluster customers based upon their RFM characteristics, recency of the purchase, frequency of the purchase, and average monetary value of the purchase. Or you're going to do some association rule mining. Association rules means that you want to detect frequently occurring associations, such as what products or services are frequently purchased together. Or you may want to consider doing some sequence rules. That means that you're going to try and detect sequences of purchases or sequences of transactions, such as web page visits. What is the sequence of pages that are being visited by your customers as they visit your website? When you build analytical models, there are various analytical model requirements that you need to satisfy, such as business relevance. It should solve the business problem. Such as statistical performance. The analytical model should be statistically sound and valid. It should detect some of the underlying patterns in the data. The analytical model should also be interpretable and justifiable. If I come up with a very complex mathematical formula using my complex tool set of academic techniques, then I'm not going to get that sold in the business, because business people want transparent analytical models. They would like to see what's going on in their business setting, be it a credit card, a credit risk, or a marketing setting. So the issue of interpretability and justifiability is a topic that we intensively study and research. Operational efficiency is also important, like how much time is needed to run the analytical model. We recently collaborated with a credit card service provider, and there we have the 6-second rule, in the sense that after a transaction was initiated, we have 6 seconds to make a decision whether the transaction is fraudulent, yes or no. Finally, there's also the economical cost aspect, like what's the total cost of ownership and the return on investment of an analytical model, and the regulatory compliance issue in settings that are highly regulated, such as credit risk modeling. The post-processing step is then going to look at the interpretation and validation of the analytical models by the business experts. There will be some trivial patterns, like if you buy spaghetti sauce, you're likely, if you buy spaghetti, you're likely to buy spaghetti sauce. That's a trivial pattern. This is good because that's a good validation. But of course, you're interested in the novel, unexpected patterns. You can then also deploy the analytical model into a business setting, and it's important that analytical models only have a limited lifespan. So that means that they have to be continuously monitored and backtested to see whether they still function appropriately. So this is in a nutshell the analytics process model together with some of the analytic model requirements. We do a lot of research on these topics in my group, and I cannot list all the research tracks, but here I listed some of the newer research tracks, like social network analytics, process analytics, and HR analytics. Social networks, when I say social networks, many people will think about Facebook and Twitter. That's not what we do, although that's also interesting. But we look at any network of people connected in a particular way. Think about a call graph, for example. Here you can see a network of people that call each other. And this is based upon data which we gathered from a real-life European telco provider. You can see all the blue dots represent customers, and the connection represents a calling pattern between two customers. So if two customers call each other, we draw a connection or an edge in the network. You will now see churners, so red ones are churners, and we'll see how the network evolves chronologically. So you can see that you can see churn behavior in the network, and all of a sudden you will see, look, these are two churners which are densely connected. That means that probably they're friends, and one of them convinced the other one to churn as well. You can see more churners, and at some point you will see chains of churn behavior. That means that if I'm, let's say, a customer from a company XYZ, and so is my friend, if I churn, I might try to convince my friend as well to churn. Here you can see a chain of 3 customers that are all friends and that have churned. Right? You can see a very big chain of customers that have churned. This is what we call a social network effect, and this is one of the topics that we're working on. We do not only apply this in telco, but we also apply this in fraud detection. Together with a PhD student of mine, working on tax evasion fraud and social security fraud, we have developed the gotcha approach. The gotcha approach is an approach that starts from various types of data sources like factual data, historical data, and transactional data, and then merges all this data into a network that we use for fraud detection. And we have found some amazing effects of using the idea of social networks for fraud detection. If you want, you can visit our website, www.dataminingapps.com, to have some more information. In credit card and social security, we found fraud to be a social phenomenon, which is really very important. Process analytics is also a topic we're working on together with some colleagues. That means that we start from an event log of an information system. You can see an event log of an information system. This could be an SAP system or any type of other information system consisting out of a case identifier, activity name, an originator, a timestamp, and together with some extra data or case-specific data. Based on this event log, we're going to build process models which are going to tell you what are the steps of your process as they take place. So we put that into one of the techniques that we're working with, and then you will nicely see what the process of activities is, sequentially then, if there are any loops, if there's any feedback chains, and so forth. This could be very useful to understand the processes in your organization into more detail. This will allow you to identify bottlenecks, to identify process inefficiencies, but maybe also process compliance issues, where you will see that there's a sequence of events that is actually taking place into your information system, but which is not allowed to take place. This is the area of process analytics. You don't see a lot of industry applications of this yet, but I expect this to become very important, let's say in the next 5 years or so. And finally, we have HR analytics. HR analytics, human resources analytics, is actually going to do exactly the same as marketing analytics, but in an HR setting. Instead of predicting customer churn, we're going to look at employee churn. Instead of predicting customer performance or customer lifetime value, we're going to look at employee performance. You can also use analytics to study employee absence or employee satisfaction. So here you can see an example of an absenteeism scorecard. It's a fictitious example, which is an analytical model, which is going to look at some characteristics such as age, function, and department. Based upon each of those characteristics, points are being assigned, whereby the higher the amount of points, the less the likelihood that the customer will be absent. Obviously, building this scorecard is a result of an analytical process model, in which you're going to run through all these steps as we mentioned them, starting from the data pre-processing up to the analytical step and the data post-processing. And once you have that analytical model in place, you can start using it to score new employees and see whether they are likely to be absent, yes or no. That's the whole premise of HR analytics. So you see there's a lot to be done in analytics, and I only have half an hour, so I quickly surveyed the analytics process model, zoomed into the analytic model requirements, and then briefly gave you a bird's eye overview on social network analytics, on how you can use it for churn detection, but also for fraud detection. We discussed business process analytics and HR analytics. Now there's a lot of more information in case you would be interested that I can refer you to. First of all, there's our website, dataminingapps.com. I encourage you to go and visit that website because you're going to find lots of information about our research there, and there's lots of free material. As I said, we have the PDFs available of my recent PhD students. We have some free movies available as well. We're also writing a lot of books. To the left is a book which I published 1 year ago and which has been quite popular. We sold about 3,500 copies worldwide of this one. It's about to get translated in Chinese as well, although I doubt there are any Chinese participants attending today. So you might be interested in that one. The right one is the most recent one. We finished writing this one 2 weeks ago. It will be 2 months ago, I mean. It focuses on fraud analytics, and it's already available on Amazon. You can already pre-order it if interested, but you will have it from mid-August onwards. It should be available. We have a lot of research partnerships with firms. These are long-term PhD partnerships in which a firm is actually sponsoring a PhD student to work on a firm-specific topic. This is the best of both worlds because the PhD student is doing state-of-the-art research using some of the techniques we developed, and is at the same time using those research findings into a business setting that is relevant for the company. In that respect, we collaborate with companies like Coca-Cola, Ageas on telematics, VDAB, which is the Flemish job service provider, for which we develop a job recommender system, Smalls, which is a government ICT provider, where we collaborate on fraud detection, bpost on churn prediction, Swipe on customer engagement, Colruyt on setting up an analytical service center, and Coca-Cola on forecasting sales. I also have 2 e-learning courses on the topic. I've seen that there are some CIOs attending the event, so if you would have employees that would be interested in taking an e-learning course. The first one is on credit risk modeling. It's very specific. But the second one is advanced analytics in a big data world. It's, it crosses different disciplines, marketing, fraud, risk management, etc. The e-learning course is a set of videos which we have recorded and that you can register for. It's not free, I can tell you that, because we worked some time to actually edit and make all the videos, but you get access after registration during 1 year to all the video material. You can play it as many times you want. It also includes demos, scripts, and quizzes for interaction. It's offered by SAS, in collaboration by SAS, but it largely focuses not that much on SAS, but primarily on the concept, the modeling steps, and methodologies. If you would be interested in more information, feel free to let me know. Okay, this finishes in a nutshell. It was a quite condensed presentation, I realized, but I'm looking forward to any questions that you may have on the topic. You can ask your questions using the chat function, and if you think that's too cumbersome, you can also engage in the audio conversation. You can just unmute your microphone and just ask me the question by a microphone. Maybe that's handier.
Yeah, only I can do that, I'm afraid.
Oh, you can do that. Okay.
Yeah. Which I'll do in a moment. I just have one question on this decision tree that you showed.
Yep.
I was wondering why this is one of your favorite method of representation, because that works well with 4 parameters. But if you use like 20, it becomes vastly complex, and probably you wouldn't be able to draw any conclusions from that, would it?
Yeah, but in decision trees, the reason I like those decision trees, they're being used by a lot of firms nowadays in churn prediction, in credit risk modeling, because of 2 reasons. One, because of the simplicity that they have. And I agree with your comment that if you have 20 splits, that the decision tree becomes also a pretty opaque and transparent structure. But I can tell you, based upon the industry experience that I have, that finding decision trees with more than 20 splits is very unusual. Usually, the average number of splits that you're going to find in a decision tree, or the average number of levels, ranges between 5 to 10. So it provides an ideal balance between what we refer to as model performance, being able to accurately distinguish the tuners from the non-tuners, that's the model performance, and the insight. In other words, being able to see or understand why customers are being labeled as tuners or non-tuners. This is very important because that insight can then be translated into business actions. Business actions like marketing campaigns, or in a fraud detection setting, this could lead up to fraud prevention strategies if you understand why a certain transaction or customer is labeled as fraudulent, yes or no.
So the decision tree is one of your favorite models of representation. What would be the two other ones?
The two other ones, yeah. Now we get a little bit more technical. Linear regression and logistic regression. Linear regression is in case you have a continuous target, like customer lifetime value. Logistic regression is in case you have a categorical target, like fraudster, non-fraudster. Let me tell you that everybody attending this presentation today, you will be the subject of at least 4 logistic regression models. I guess most of us have credit cards. Your credit card service provider is going to score whether you're going to become a defaulter, yes or not, based upon the behavior on your checking account yesterday and the days before. That will be run today on your behavior. It will not only be done for your credit cards, it will also be done for your installment loan, your car loan, your mortgage, right? Also, your telco provider might use logistic regression to see whether you're going to churn in the next 3 months, yes or no. So logistic or linear regression is my second. And my third is random forest. And that's very technical. I cannot clarify this in this very short time frame. But you can think of random forest as a bunch of decision trees. It's a forest, so it's a collection of decision trees which outperform one single decision tree. Instead of estimating one single decision tree, you build a random forest model. And if you're only interested in performance and not that much in interpretability, and in certain settings this is the case, then random forest consistently provide you with the best performance statistically.
Okay, thank you for that. We've got a question from Kalman. Kalman, I'm going to unmute you in order to be able to ask your question directly because I'm not sure I understood it correctly. So Kalman, good morning, first of all. Kalman?
Kalman? I see a question here in the chat box. Let me see.
Yeah.
I will first read it, right? So I'll just write data comment from Internet of Things requires a different approach as far as analytics is concerned. Instead of storing query, is filter and keep only what's necessary. How are you looking to this evolution? Yes, that's right. The Internet of Things is going to be massive, right? We are working on this in telematics. And from a data perspective, this indeed raises some important challenges. Let me just clarify the issue of telematics. Telematics means that on your iPhone, you're going to have an app which continuously monitors your driving behavior. So it's a very discontinuous stream of data. As soon as you jump into your car, it's going to start recording. If you stop for a traffic light, it's going to stop recording. So you have a very discontinuous stream of data, which is going to pose serious challenges for the gathering, but also for the analysis. That means that the data transfer, first of all, the data storage and the gathering will pose important challenges, but also the analytics that you're going to do with it and the transformations. Because at the end of the day, the data needs to be transformed in such a way that it is suitable for analysis using analytical techniques, such as decision trees. So data transformation is one of the topics that we will be working on in telematics. But you're going to have other settings as well, like recently we spoke to a firm producing compressors in the industry, where they equip their compressors with with internet addresses, so they hook them onto the internet, whereby they continuously generate data about the functioning of the compressor. So it's an incremental data stream that you're basically generating, and where real-time analytics will be very important, because it means that as soon as you see that the compressor starts to malfunction, you need to be able to shut it down in order to provide further damage. So it creates a lot of challenges from a data storage perspective, a data transformation perspective, from an analytical perspective, in the sense that you're going to need a lot more real-time analytics, more than ever before.
Okay, thanks for that. I see no other question on the chat, so what I'll do is unmute everybody and see if anybody has a question that he or she is willing to ask live.
So I don't know if you can hear me now.
Yes,
I can hear you. Yes.
Okay, so apologize because it was a problem. So honestly, because we are confronted with this question that you have just described from data coming from the machines, and this is the whole challenge: how to build filter mechanism as close as possible to the event place. And in this moment, we are running against not just to deal with transferring the data, but also to two phase of filtering, one as close as possible to the event, and afterward the real data analytics, which has to happen in the very classical way of data analytics, which is quite challenging. What I have to do as close as possible, as because you don't have the latency to deal with, and what you have to take over. So this in IoT context keeps to be a challenge for us.
Yes, that's right. If you do analytics, the first step is that you have to understand your process, right? And understanding your process comes with business knowledge and comes with collecting as much as possible data, and as you mentioned, as close to the event as possible. And then you have to see, it depends upon what you want to do with the data. Do you want to study fallout of your machine, for example? Then you can start building analytical models, and those analytical models are going to give you insight into what are the key mechanisms, the key events which are going to trigger a fallout of your machine. And once you have that insight, you can actually speed up the whole process, because now you can collect data closer to the event, but you don't have to collect all the data, but only the one that's really relevant, and that will indicate a fallout in the near future. So it's a bit of a thing that you have to do, it's an investment that you're making in understanding the business processes and the phenomenon like fallout, using analytics, and then try to make sure that you gather the right data with the right quality in order to speed up the corresponding business decisions.
Okay, with that, I'm going to close this session. A very warm thank you to Bart for this session. I think it was really a very good, strong introduction.
Thank you very much for attending this, and maybe we see each other again, either virtually or either face-to-face at some future analytics event.
Absolutely.
Bye-bye.
Thank you, Bart.
Thank you.
Bye.
Bye-bye.
Bye, everyone.